Hello guys, welcome to a new video about malware analysis. Today we are on Flare VM and we are going to be taking a quick look at an obfuscated patch file, this one, that invokes a PowerShell script and then runs the XWorm RAT in memory. So the XWorm RAT is a really powerful remote access software that is very popular and widely used as an option to spy on the person who runs it. We can see some of the capabilities here. It has also the option to encrypt all files, hidden RDP, add itself as an exclusion in Windows Defender. We can see it also can keylog, view your webcam, which is pretty unwanted if you ask me. And this is quite unique because it runs it purely in memory, which means there's actually no XWorm RAT file on the disk, but only in memory, which is used to bypass antivirus detection. So first, let's take a look at the AnyRun scan of this file. We can see that I extracted it and then I ran the batch file, which showed a CMD window and then just disappeared. We also saw this command, which is going to be really important later on. So let's see what it actually did. So here we can see that we just ran it. Okay, starts consoles as normal. And here it echoes a long string of PowerShell commands that are going to be important later. We're going to actually take a look at this exact thing here. So here we can see the PowerShell is started, loads an assembly, gets or sets the symmetric key, which is going to be also important a bit later, and launches itself again, does the command again. Okay, here we can see VS script that starts a VBS file, another command line, and here we can see the PowerShell that connects to the command and control server of XWorm. This one on port 1000. As we already mentioned, whatever the threat actor wanted to do to this PC, he could just do it through the dashboard that we saw here. So, now that we looked at its behavior and what it's supposed to do, let's actually open up the bash file to see what is inside of it. Okay, so let's get into it. We are going to open Notepad++. It's a really useful text editor that I recommend, and we'll paste the batch file into it. Okay, so we are met with some obfuscation here. We can see it's pretty much on many parts, on like 100 variables. Then we can see the variables glued together. Here we can see that it exits actually. And then here is some extremely long string that we will take a better look at later. But now let's actually look at the batch file itself. So here we can see that it sets echo off, which is used to stop the commands printing on the console on repeat. So we can just remove this and add echo off. Okay, so now we could actually do this manually, but that would take us quite a lot of time. If you wanted to do this manually though, it would be something like this, that we copy the variable, then we will do, the variable name, of course, not the content yet, the variable name with percent on each side, because bash file uses percent to write a variable, and then we copy the content of it, we do replace all, and then we just delete this, and we just do it again like that. So like this. This would be pretty much the decryption process of this. Maybe somewhere it's already decoded. We see it anywhere? No, that's fine. So instead of manually obfuscating this, we can actually look into the AnyRun scan. We're gonna see it starts with echo clear screen, then we have some function, decrypt function. So let's see if you actually find something like this in the process of AnyRun behavior. So we can actually just see it straight from here. Here we have the command line command, and we have pretty much the full thing that we just looked at. So let's open a new node, and we can see that here it ends like payload 3 var string. So let's see if it's actually that. PowerShell, okay, that's fine. This just starts the PowerShell. This is a command to execute another command on the same line in CMD. But we can actually see that it executes the function payload 3 var. And yes, so this is exactly it. So now let's beautify it for a bit, because this is ugly. Okay, we can't really see anything from this at all. So let's remove the cmd.exe first, because that is not important anymore. The clear screen is also not important. And now we need to note that the semicolon is used pretty much as a new line for a new command. So what we can do is we can paste the semicolon here, and we can do n for a new line, and we also enable the extended search mode here. So we do replace all, and now we can see that it actually looks way better. We will also use the PowerShell language. Wow, perfect. Okay, this looks good now. So we are now looking at a decrypt function. We can see the AS key here from base64. Okay, nothing that interesting. We can see some decompress function. Okay, interesting. Execute function doesn't really matter now. Okay, this is interesting. We can see a file path and a file name here being set to this variable. Since we grabbed this from the AnyRun VM, we can actually see that it executed on desktop and it was exactly this file name. We can also see it from the script itself that this is pretty much equivalent of the file path and file name in batch. So that is pretty cool. We can see that we read all text from. Ooh, interesting. So this sets the window title of the batch file, and then this reads from the title. That's pretty much the batch file, and then it does a loop here. So what we can do is that we are going to rename all the variables so we fully understand this. So let's rename this one to batch file window title. Sorry, like this, okay? We replace all. Then we replace this with the read all text from batch file. Okay, replace all. Okay, then we have the this variable, which is the looped batch content. Okay, now it looks pretty good. So we can see that it loops from all the batch file text. And if it starts with this string, then it sets this variable, key rew, pretty much the string, but without this. This is 20 letters long, so it will pretty much cut this thing out of it. So let's copy this and let's look in the batch file to see if we can actually find something like that. So let's do find, paste this in, find next. Oh, okay, we can actually see something like that here. This is after the exit, so we can assume this is some another form of encoded payload, and then it does some stuff with it as well. For example, splitting with this thing, and what it does is that it decompresses, decrypts, decodes from the base64, then it replaces some characters, and then it executes it. So here we can see that it actually has 3 payloads, which is interesting, because from the AnyRun we only saw one of the payloads only. So what we are going to do is that normally we would write the decryption script now, but I have actually already done that. So let's take a look at what it does. So this is pretty much the same script, but except of executing the payloads. We just decided to forward it into a binary file if it's binary, or just directly into the console if it's plain text, of course. So nothing here really is changed, because if we change anything here, it would just stop working, because it's of course encrypted using the AS. Okay, decompressing also default. So here we added to check if it's a text or binary data. Here we load the base64 string in file.txt. Okay, so we need to create a file.txt, and we will put the encrypted string, this including the 20 characters at start it was looking for. We put it in the file.txt and save it. So it does the same looping process as the malicious file did. It looks for this string start, then it cuts it off and sets as this variable. Then the payload var is this variable, but it splits it with this character. And then we do base64 decode, then we decrypt it and decompress all the three payloads in it. And here we just resolve if it's a binary or a text. So let's go to our command line, run as administrator, change directory to desktop, and execute the PowerShell decode file. Okay, so now we got three binary files. We are going to open PeStudio to see what they actually are. So let's start with, of course, with payload 1. Okay, so we can see it is an executable. The original file name cxwm.exe. Okay, nothing entirely interesting here. We can see the entropy at 5. This pretty much means the higher the value is, the higher level of obfuscation it has. So this is actually not that high, so it's alright. Okay, we have 44 virus tunnel detections. Interesting. Mostly as hack tools. So if we look at the strings here, those are not obfuscated at all. So the script is not really protected or anything, but we can see some weird strings named com_antivirus.dll, for example, aswmc.dll. Okay, interesting. Anything else? Oh, okay. Okay, now we can see some antivirus software names. We can see Norton here. We can see Malware, Bytes, Kaspersky, F-Secure. Okay, ESET, Bitdefender, Avast. Okay, so injecting VM hook code. So this is pretty much a hack tool to evade the antivirus detection, which it was pretty good at, honestly. It did bypass the Windows Defender and Malwarebytes successfully. So the only thing blocked from Malwarebytes was the connection to command and control server, but the files itself were not blocked at all. So let's take a look now at the second file. So once again, we are going to start PeStudio and paste in the payload2.bin. Okay, so we can see another executable, and the entropy level is even lower than before. So this file is definitely not packed, compressed, or anyhow protected against analysis. We can see 41 virus total detections. Okay, interesting. Most of them are for MC bypass. So this is actually a really interesting program. This allows the script to bypass the detection by using several methods of evasions, like base64 encoding, PowerShell downgrading, hooking, memory patching as well. This one specifically is using memory patching to bypass the detection of the running PowerShell script that stores the XWorm RAT in it. So it's actually really interesting reading. I will put this link in the description in case you want to learn more about this. But just for our purpose, it's enough that we know this is a hack tool used to bypass the detection of the Fileless XWorm RAT. And now it's time to look at the last payload, the payload 3. So let's open PeStudio for the last time today, paste it in as always, and okay, the entropy level just got really high. Just for your info, the entropy level maximum is 8. So the 7.9 is actually extremely large. The 51 detections, alright. Are there any softwares that are like naming it specifically? We have shell loader here. Okay, we have MSL XWorm again, so Symantec actually knows that this is the XWorm. That is interesting. But other than that, there's mostly just generic detections. There's not really much we can figure out of this, though there are some interesting strings here that we can look at. Let's look at the flagged ones. We have virtual protect, which is used for memory manipulation. We have shell execute, which is used to run CMD or PowerShell, which is interesting. Let's scroll a bit in case we can see something specific in here that could give us some. Okay, we have Windows style, nothing really interesting so far. Okay, this looks like some encoded text. Okay, we have payload.exe, PowerShell.exe, okay. So it's probably, okay, here we can see some basic D4. This is, I'm pretty sure this is the AS key that we looked at before. I'm not entirely, okay, it's not, my bad. So let's scroll further. Okay, nothing entirely interesting here. Another encoded string. Okay. Creation flags, alright. Already injected PIDs, okay, this is interesting. We have, okay, this is interesting. This looks like the PowerShell syntax of creating a new scheduled task to run at logon. So, okay, interesting. Let's scroll further. Okay, here we can see mentions of the file names, the phantom startup string.vbs. I actually have the VBS here on desktop as well. It's not really interesting. All it does is it just runs the batch file that starts the XWorm RAT. So the VBS is nothing really important. Okay, let's scroll further here. We have, okay, nothing interesting here for us. Okay, version info, interesting. Okay. Okay, here we have another scheduled task. Alright. Okay, anything else interesting here? I'm pretty sure there was something else still. Okay, here we can see some mentions of base64 encryption. I mean encoding. It's not really an encryption. Okay, here we can see that this is a Visual Basic script. So what we can tell from this is that the XWorm file, this one that is called in memory, actually created the VBS file I opened here a few seconds ago. So this is the file that creates it. Okay, is there anything else interesting we can see in strings? Okay. Doesn't look like there is. Okay, another encoded string. Alright. Okay, another. Okay, this is interesting. Here we have some. This is a registry key, so it probably sets the registry key to start on logon as well. so it's not only scheduled tasks. Here we have, okay, nothing new. Okay, so from strings, this is pretty much it. We are also going to look at CAPA to see what capabilities it has. So builder CAPA payload 3.bin, and let's see it. Okay, so defense evasion. It deobfuscates and decodes files or information. We already know that. Process injection, we also found that out. Scheduled task or job. Registry run keys, we also found that in the strings. So here we have another persistence, memory, allocating memory, okay. This is used for process injection. Data decoding, okay. Compress data using gzip, okay. Decoding data using base64, we also know that. Nothing really new. Scheduled task, of course, run key, suspending thread, also used for injection. Session integrity level. I'm not entirely sure what that means. And we can actually, just for fun, we can actually use the CAPA on all of the 3 files that we were looking at. So the payload 2, if I remember correctly, was the MC bypass. So here we have the manipulate unmanaged memory, allocate or change RVX memory. Okay, allocate memory. Yeah, so this was exactly what I was talking about. It uses the memory patching to pretty much tell the Windows Defender that there's no detection. So yeah, this is a really big security flaw. And let's do it at payload 1. Okay, there's not much interesting stuff here, just about cryptography, okay. Console buffer, yeah, nothing really interesting here. So what we did today was we analyzed the batch file, the PowerShell script that the batch file calls, and we extracted all the 3 payloads that it called, and we also explained what each of the payloads does and how does it work. This was actually pretty surprising to me because this sample was almost a year old. I would actually expect this in like the new CAPTCHA attacks because along with Luma and other stealers, XWorm is pretty popular as well. So yeah, thank you for watching this video. I hope you actually learned something from this,